Hello everyone. In this lecture, we will discuss the inventory control models with shortage. In the previous models, we discussed the EOQ with assumption of shortage and back ordering are not allowed. So these models are trade-off between the ordering cost and carrying cost. So in the previous model, just we are considering the variable cost is in the terms of the ordering cost and the carrying cost. Then we determine the EOQ. Here we discuss the inventory control with shortage. Now question it will be raised, what is the mean by shortage? Shortage of items occurs when the items cannot be supplied on demand due to delay in delivery or demand becomes more than the expected demand. So not receiving the inventory items at respected time due to the delay in delivery or huge demand. And what is the mean by back ordering? Back ordering an items is the shopper can buy the item now and receive it at a future date when the is in stock and available. So back ordering means receiving the few items later when it available. In these models, we discuss the inventory with allowing shortage. So next is the what you mean by shortage cost. It is the penalty cost when there is shortage on out of stock. We are representing in the CS. It is the rupees per unit per year. So let's see the shortage. The shortage can be viewed in two different ways. First one is the customers are ready to wait for supply of item. So here customers are waiting. So we are not losing in the sales point of view, but we have to spend more amount of the amount in the terms of the back ordering cost and extra paperwork. Second one is the customers are not ready to wait for supply of item. Obviously in this condition, so we will lose the customers. It will be effect in the loss of sales. Obviously result in the loss in the revenue. So let's see it in the second view. Customers are not ready to wait for supply of items. In this case, an organization may suffer with a loss of customer goodwill and therefore causes loss of the sale. The loss of goodwill is expected to increase in proportion to the length of the delay and causes decline in growth of the business due to loss of potential revenue. So this shortage cost is the penalty cost, maybe in the terms of the loss of revenue, or maybe it is in the terms of the extra cost in the terms of back ordering cost and extra paperwork. So shortage cost is the penalty cost when there is shortage on out of stock. So now question it will be raised. So shortage is an advantage or maybe it is the drawback. So let's see. First we have to discuss with the inventory model with shortage. So first we have to see the inventory without shortage. In this condition, starting of the cycle, so with the receiving order quantity capital Q at instantly, and it is consumes gradually and it will become the 0. Then once again we have to build up the inventory and once again it will be consumed and it will become the 0, and it is the repeated cycle. So here, so this area is representing the inventory carrying cost. Let's see the inventory with the shortage. So here I am allowing this shortage. So this is the actual requirement inventory. So here this shaded area is the actual requirement inventory, and this is allowing for the shortage. So after the certain time, it will be delay in the time to receive the expected quantity. So this is the delay in time. So the shortage is allowing. So let's compare with shortage and without shortage. In this condition, this is the with shortage condition. So this is only the inventory carrying cost. So this is only this area only the carrying cost. But in this previous one, so without allowing the shortage one, so this total entire area is become the carrying cost. So I have to observe that one. With allowing the shortage, it is the reduction in inventory carrying cost. So here inventory carrying cost is reducing. However, it will be influence on the sales and increase in shortage cost. So here in these models, we have to trade off between the carrying cost, ordering cost and shortage cost. Then we will decide the how much shortage can be allowed to get an economical order. Now we will discuss the EOQ model with constant demand and variable order cycle time with shortage. Let us consider this model is 2A. In this model, assumptions are similar to the model 1A, which is we discussed in the lecture number 5, except the shortage. So in this model, shortage is allowed and the cost of the shortage is assumed to be directly proportional to the average number of units of shortage. Let us consider the following notations are using in this model. That is the T1 is the time between the receipt of an order and when the inventory level drops to 0. So it is the time when no shortage exists. T2 is the time during the which backorder or shortage exists. And T is the total cycle time, which is the T1 plus T2, and capital R is the maximum shortage. This is the schematic representation of this model. Here T1 is the, so this is the T1. T1 is the time between the receipt of an order and drops to 0. So here there is no shortage exist. And T2 is the shortage exist. So this time period is the having the shortage time. So this is the in this period T2 time shortage is existing. And T is the total cycle time. So this is the T total cycle time or reorder cycle time. So it is the T1 plus T2. So it is the time between the no shortage existing as well as time for the shortage existing. So this is we are calling as the reorder cycle, that is the total cycle time, that is the T1 plus T2. And one more thing here, capital R is the maximum shortage. So here this is the maximum shortage. So this is the total shortage. Here it will come the maximum shortage. So this is we are indicating the capital R. So here we are receiving the quantity capital Q. Then first we have to fill the shortage amount. So this is the shortage amount. Then remaining quantity let us consider M, placing in the inventory. Then shortage will become the Q minus M. So here M is the quantity placed in inventory, which is the deduction of shortage in the inventory. So here capital R, that is the shortage units, equal to the Q minus M. So here capital M. So shortage units, that is the Q minus M. Every time the quantity Q is received, all shortages are equal to amount R are first taken care of. So here first we have to fill the shortage quantity capital R when receive the quantity capital Q. So here we are receiving the order quantity, that is the capital Q. Then we have to fill the shortage, that is the R. 1 minute, we have to erase it. So here, so we are receiving the Q quantity here. First we have to fill the shortage quantity, that is the capital R. First we have to fill shortage quantity, that is the capital R. Remaining quantity we have to keep in inventory. That is remaining quantity we are calling as the capital M. The remaining quantity M is placed in inventory as the surplus will be used to satisfy the demand during the next cycle. So remaining amount, this is the M amount we are using for the next cycle, that is up to the T1. When there is the T1 is the time, so there is a no shortage existing time. So this quantity M we will be used up to the T1. The R units of an item out of order quantity Q are always in the shortage list. These are never carried in stock. Thus, it yields savings on the inventory carrying cost. Here observe that when the shortage quantity capital R is out of order quantity. So this is the out of order quantity. This is the shortage and out of order quantity. So quantity capital R, that is the shortage, is not considering for the carrying cost. So in this carrying cost we are not considering the shortage amount. So in the carrying, this is the actual inventory cycle. So in this one we are considering the only M quantity. We are not considering the shortage quantity. So as well as the carrying cost also, we will be not considering the shortage units. Next we will see the total inventory cost. We know the total inventory cost is the purchase cost plus ordering cost plus carrying cost. But in this model we are allowing the shortage. Then we have to consider the shortage cost also. Then the total inventory cost for this model will become the summation of the purchase cost, ordering cost, carrying cost and the shortage cost. We know that when the purchase cost is nothing but it is the annual demand D into the unit price, that is the capital C. So purchase cost is not depend upon the order quantity Q and the stock level M and the shortage quantity R. So it is the fixed cost. It is not a variable cost. So it is the fixed cost. So remaining the cost is that is the ordering cost, carrying cost and shortage cost is the variable cost. So these three are the variable cost. Here our intention is, objective of this model is we have to find out the optimum order quantity Q star and optimum stock level, that is the M star, and also have to determine the optimum shortage level, that is the R star. So these three is depend on the Q, M and R. So for this one we have to determine the Q, M, R. For this one I have to consider the only variable cost, that is the, so I have to write down the total variable cost equal to ordering cost plus carrying cost plus shortage cost. So I have to determine the optimized cost. For this one I have to determine the TVC star. So for this one I have to consider the only ordering cost and carrying cost and shortage cost only. We are not considering the fixed cost, that is the purchase cost. Since in this inventory system, except for the purchasing cost, so this purchase cost is the fixed one. Remaining all other costs such as ordering cost, carrying cost and shortage cost depend on the decision concerning with Q and M. Therefore, objective is to determine the optimal value of order quantity Q star and optimal stock level M star along with optimal shortage level R star. For this one we have to optimize the total variable cost. We know the total variable cost is the summation of ordering cost plus carrying cost plus shortage cost. Purchasing cost is the fixed one and we are not considering. Then we have to determine the ordering cost and the carrying cost, then and shortage cost. So first we have to determine these ordering cost and carrying cost, shortage cost in the terms of the Q, M and R. First we have to determine the time period values. We know time period, that is the total units over time period divided by the demand in units. Let's see the time T1. So this is the time T1. So in the time T1 we are not allowing the shortages and we are maintaining the positive inventory level. So then T1 will become the total units over time period. So in this time period, so we are having the units is M units. So up to here M units it is having with respect to the total annual demand, that is the D. So T1 will become the M by D. So next we have to see the total cycle time. What do you mean by total cycle time? So total cycle time it will become the T1 plus T2. So T. So and also here also same thing. How many quantities here in this time period we are having? Order quantity. See here at the starting of this time we are consuming the total quantity, that is the total order quantity, that is the capital Q. So T we can be written as the Q by D. Similarly we have to next see the T2. What do you mean by T2? It is the time period which is the shortage are allowing. So within this time period we are allowing the shortage. So how much shortage we are allowing here? R quantity we are allowing. What do you mean by R? That is the Q minus M. So T2 will become the total units over in this period, that is the Q minus M divided by the total demand. So next we have to determine the average inventory level over the reorder cycle time. So here we have to determine the how much inventory level. So with the time period small t. So average inventory level can be written as the average level over T1 time and also average level over the T2 time. So let's see this one. So it is the average level over T1 time period. How much average level of inventory we are maintaining here? So this is only the inventory level. Here maximum is the M and minimum is the 0. So M plus 0. So average will become the divided by 2. And the over the time period, that is the T1 plus similarly average level of average level of inventory in the T2 period. In this period we are not considering the any quantity for the inventory. So it is the 0 into T2. So divided by the time period, that is the T. So that is this is the M plus 0 which will become the M by 2 into T1, 0 into T1. This we have to write down the M by 2. So this I have to write down M by 2 T1 by T. So we know the relationship of the 1 minute, we will be erase this one. So we know the values of the T1 and the T. So here this equation will become the M by 2 T1 by T. We know the T1 value, that is the M by D, and T also we know that is the Q by D. If you substitute the T1 and T here, this equation, that is the average inventory level, will become the M square by 2Q. So we know that when the carrying cost, that is the average inventory level into So carrying cost for the unit per year, that is the CH. So carrying cost will become the M square by 2Q into CH. Next we have to determine the shortage cost. But before that one, have to determine the average shortage level. Here also same thing. Over the time period, that is the order cycle time. So we have to consider the average shortage. First we have to consider the how much shortage is. We are considering the time period T1. In the T1 time period, average level of the shortage. Similarly, in the T2 time period, average level of shortage we have to consider. Here there is no shortage. So in here we are considering the only inventory quantity. Here there is no shortage. Obviously it will become the 0 T1. Here maximum is the R, that is the Q minus M, plus minimum is the 0. So 0, average will become the by 2 into the time period, that is the T2. So this will become 0 into T1. Why it is a 0 considering? Here we are not considering the any shortage. Plus average shortage, that is the maximum shortage, that is the Q minus M, plus minimum shortage is the 0 divided by 2. Average you have to consider, that is divided by 2 into T2 divided by T. So here we know the T2 values and also T values. That is, so Q minus M by D divided by Q by D. Obviously dd will cancel. It will become the Q minus M divided by the Q. So it will become the Q minus M square divided by 2Q. Next, shortage cost will become the average shortage level into the shortage cost per unit per year. That is the shortage cost will become the 1 by 2Q into Q minus M whole square into CS. So next we have to determine the ordering cost. Ordering cost is nothing but number of orders. Number of orders will become the D by Q into the ordering cost per unit per year, that is the C naught. So ordering cost will become the D by Q into C naught. So we know the carrying cost as well as shortage cost. Then I have to write down the total variable cost will become the ordering cost, that is the D by Q into C naught, plus carrying cost, that is the M square by 2Q CH, plus shortage cost, that is the Q minus M whole square divided by 2 into Q CS. So here observe that when the total variable cost is the function of the two variables, that is the Q and M. Therefore, in order to determine the optimal order size and the optimal shortage level, or differentiate this total variable cost function with respect to the Q and M. So here I am not doing any differentiation. If you do the differentiation with respect to this TVC with respect to the Q and M and equating the 0, then we will get the Q star, that is the root of 2D C naught by CH. So this is the common into CH plus CS divided by CS. So Q star will become the root of 2D C naught by CH into CH plus CS divided by CS. And M star will become the root of 2D C naught by CH into CS by CH plus CS. This is the M star, that is the optimal stock level. If you substitute these two, we will get the optimal total variable cost, that is the root of 2D C naught by CH into CS by CH plus CS. This is the optimal inventory cost, that is optimal variable inventory cost. And remaining two formulas, these important formulas we have to remember. So one is the optimal shortage level, that is the R star will become the Q star minus M star. So Q star minus M star, we will get the Q star into the CH divided by CH plus CS, and total cycle time, that is the T equal to the Q star by divided by D. So Q star divided by the D, we will get the equation is 2 C naught by D into CH plus CS divided by CS. So you have to remember this all the formulas to solve the problems, that is we'll discuss in the next session. Thank you.